Hi, today's lesson is an introduction to functions. So in math, functions is actually something you've been dealing with since grade 9. We just didn't call it a function before. So today we're going to actually formalize what a function is. So a function, first of all, is denoted with a fancy little cursive F like that. And it's like a box with a special rule. So here's a box. You have some input. Okay, then bloop, 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 a rule happens. And you get some output. So a real world example would be, let's say you take movie titles. So let's say Avatar. And you want this machine to spit out the first letter of that movie title. Well, it's going to spit out A. So the input is the movie. The rule is to spit out the first letter, so it spits out A. So that's a non-math example. But what about a math example? Well, let's say you take a number, like 0, and then you put it through an equation, like 2x minus 1, and then it spits out an output, in this case, -1. Or you could take another number, like 5, and it would go through the equation, and it would spit out 9. So in an equation, in math, your input is a number, and your output is also a number. But what's special about a function is that each possible input only has one possible output. So in our movie example, when I put in a movie, there's only one possibility that can come out for the first letter of its title. In this case, Avatar, you can only say that A is the answer. It could never be anything else. Same thing with this equation. When you put in 0, you'll never get anything else but -1 when it goes through this equation. That's how you know that something is a function, if there's only one possibility for what can come out. Now, let's say if in our movie situation, instead of first letter, we had number of stars, or a review rating. So let's say that Avatar, how many stars did it get? Well, maybe somebody gave it 5 stars, but maybe somebody else really didn't like it and gave it 2 stars. That would not be a function, because you can have 2 different possible outputs for the rating of Avatar. You could have 5 stars or 2 stars. So that's not a function. Okay? So again, back to math. The input is all possible values of x, which we call the independent variable. So this is the set of all possible values. So you're basically asking yourself, what can x be? So this is what x can be. Or you can think about it as all possibilities for x. Okay, so in this example, x can be anything. Anything can go into this equation. For our first example, the set of the possible values for the independent variable. So that would be what your input is, so any movie title in the world. So it wouldn't include song titles, it wouldn't include numbers, it would just include anything that is the title of a movie. Okay? So then the output is the possible values of y, or the dependent variable. So then the range is the set of all possible values of the dependent variable. So this is basically what y can be, or all possibilities for y. So this is your output. So again, in this example, your output, the range, is any number, because any number could come out of that. But in our movie example, the output would be any letter in the English language, so A through Z. So you would have 26 different possibilities for your output. Even though you have a bajillion different movies, there's only 26 different answers that you could be. So your range would be all letters A through Z. There are 4 ways to represent a function, and you're responsible for understanding all 4 of these. So So the first is numeric, which is a table of values, or an ordered pair. So that's just a set of numbers written like this, x, y, the x value first and then the y value. So again, the set of all x values can only have one possible output, y. So -1, 1, 0, 0, 1, 1, 2, 4. You might recognize it. That's a set taken out of the function y equals x squared. So this is a table of values, and I can also write it as a set of ordered pairs. So xy, 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 xy. So how do I know this is a function? Well, each x value only has one y value. So -1 only has 1, only corresponds to 1. 0 only corresponds to 0, etc. Now you might be saying, but there's two places where 1 shows up. See, it doesn't matter if there's two different y's that correspond to a different x. All that matters is the other way. Each x has to only correspond to one y. And since that's the case, then yes, this is a function. So this is a function because each x corresponds to only one y. So it might help you a bit more to see something that's a non-example, so something that's not a function. So let's start again with -1, 1. But for 0, let's put 0 and 5. 1 and 1, 2 and 4. Okay, so the ordered pairs here would be -1, 1. But then this results in 0, 0 and 0, 5. 1, 1 and 2, 4. Okay, notice that the x value of 0 has two possible y values. Y could either be 0 or y could be 5. So since there are two possibilities, this is not a function. Since there are two possibilities for the x value 0. Now you might be wondering about domain and range. So if we go back to here, our function, the domain is all possible x values. So in this case, -1, 0, 1, and 4. And our range, think about it, would be the possibility of y. So think about this. 1, 0, 1 again, so I don't need to rewrite it, and 4. Visually, a function can be represented by a mapping or a graph. Now, a mapping looks something like this, where you have your x values written in an oval, and your y values also written in an oval. And so you write your corresponding answers across like that. So this is clearly a function because each x only has one y. Something that's not a function would be if one of your x values, let's say 0, corresponded to more than one answer. Okay, so right here, because this x value has more than one answer, that's not a function. Now in a graph, let's take a parabola, for instance. How do you know that's a function? Well, each x value, when you go up to the function to find its corresponding y value, there's only one possibility. But in something like this, if you take a given x value, watch, it hits the function not in just one place, but two places. So that means that this x value corresponds to one y value, two y values, more than one y value. That's not a function. So what you have to consider is the vertical line test. So if you would take a vertical line and draw it across the function like this, if it intersects the graph of relation more than once, anywhere, even if just one time it hits it more than once, then you can say that it is not a function. Okay, so imagine a vertical line like a ruler or a pencil or something like that. If you take it and drag it across this graph, there's nowhere that it hits the graph more than once. But if you take that same vertical line and drag it across something like this, you'll see that there are many places where it hits the graph more than once. And in fact, that only needs to happen one time in order for something to not be a function. If there's even one place where a vertical line has more than one y value, then it's not a function. Okay, so algebraically means looking at equations. So if you look at an equation, how do you know if it's a function or not? Well, any linear equation, anything in the form y equals mx plus b is a function. Because if you put something in for x, you're only going to get out one possibility for y. There's never more than one choice. Same thing for any quadratic. Okay? It's always going to be a function. But what about something like this? Now this is the equation for a circle, which you might remember from grade 10. Okay? Now look at this plus or minus. It's going to be a problem, right? Because if you put in 3 into the function, 25 minus 9 is 16. The square root of 16 is 4. Well, this plus or minus means that you could get y equals 4 or y equals minus 4. Two possibilities, not a function. So anytime you see a plus or minus like that, that tells you right away, not a function, because this value of x could have more than one possibility for y. Now there's also a description, which is another way of representing a function or something that's not a function. So here's an example. A taxi company charges $2, that's just a flat fee, but this is what's important, $1.50 for every kilometer driven. So that means that the independent variable is kilometers driven, and the dependent variable is price of a taxi ride. So the price of a taxi ride is a function of the kilometers driven. So that means if you drive a certain number of kilometers, there's only one possibility for the cost of that taxi ride. For instance, if you drive 0 kilometers, it has to cost $2. If you drive 2 kilometers, that's $2 plus $1.50, that's $5. So if you drive 2 kilometers, you can only ever cost $5, nothing else besides that, under this fee structure. But what if we look at time? This is not a function. The price is not a function of time. Why, you ask? Well, let's say you're driving for 10 minutes. What you have to say is, if I put in 10 minutes, the input, could I only get one output for price, or could I get many different outputs for price? The answer is that you can get many different outputs. Because if you're driving on a highway where there's no stopping at all, that could mean that you're, driving 10 kilometers, 20 kilometers, whatever it may be, and that could cost you quite a bit of money, because it's dependent on the kilometers. But if you're driving 10 minutes in a big traffic jam, let's say you really only make 1 kilometer on that trip. That's only going to cost you, not that much money, $2 plus $1.50. So one input for time could give you many different answers for price, so it's not a function of time. So what you always have to ask yourself in any of these 4 representations is, when you have a specific value of x, any value of x, can you have more than one value of y? When you're looking at the independent variable, how many options do you have for the dependent variable? If there's only one, then it's a function. If there's more than one, even one time, then it's not a function. So you have to be able to, in any of these 4 representations, give me an example or a non-example, or you have to be able to come up with your own example Or you have to be able to, if I give you an example, tell me if it's a function or not a function.